For the second day of our similar figures chapter, we're going to just focus in on similar triangles. Yesterday in day one, what we did is took a look at how to solve proportions, so just a real quick review of proportions, but then took a look at similar figures and saw that in order to find a missing side, you have to set up a proportion and cross multiply. What our goal is for this chapter is to move into actually proving that triangles are similar. So we're going to play around with making sure that we actually know how to deal with similar triangles or similar figures and then work our way into proving them. So we're going to start off early on in this chapter with looking at the 3 ways that you can prove that triangles are similar. So these are very similar to what we did last chapter, but different. So I want to take a little bit of time in a couple of the videos to make sure that you see how to prove triangles similar. We're not actually going to do a proof today. We're just going to take a look at the methods. First method is completely different from congruent triangles. The first method is angle-angle. Now, we saw, if you remember back to the day in class where we looked at Geometer Sketchpad, where we had the triangles and we tried to make them exactly the same, when we did angle-angle-angle, what we saw is that you could make a whole bunch of triangles that were the same shape but different sizes when we fixed the angles. So, angle-angle doesn't prove that triangles are congruent. It proves that they're similar. And the other nice thing is that we don't need all 3 angles because in a triangle, they have to add up to 180. All 3 angles have to add up to 180. So if you know 2 of them are the same, the third pair has to be the same. So angle-angle is our first way of proving triangles similar, and it actually turns out to be the one that we'll use the most. We also can show side-side-side and side-angle-side, but these are completely different from congruent triangles. Yesterday in the video or in the notes, we said that when you prove or when you are looking at similar triangles, the sides have to be in proportion. So if you were to compare sides, they have to reduce down to the same fraction. So anytime you're going to use something with sides in it to prove that triangles are similar, you have to show that the sides reduce down to the same fraction. So you're not showing that they're the same length. Same length would make them congruent. What you're doing is showing that they reduce down to the same fraction. So just to kind of talk about them a little bit more, angle-angle, to show that triangles are congruent using angle-angle, you have to show that you have 2 pairs of corresponding angles that are the same size. Okay, so here, if we knew that triangle or that angle A was equal to angle D, and angle B was equal to angle E, then that's enough to say that those 2 triangles are similar. Again, not congruent, similar. Side, side, side. Again, be careful. Side, side, side for similar triangles is not the same that we used for congruent triangles. To show that triangles are similar, it's enough to show that the 3 sides are in proportion. And again, what that means is you want to show that the 3 sides, the 3 pairs of sides, all reduce down to the same fraction. So if we can show that the fraction from comparing AB to DE, the fraction comparing AC to DF, and the fraction comparing BC to EF, if we can show that those are all the same fractions, they reduce down to the same fraction, then that's enough to say that the triangles are similar. And then the last one's side angle side. And again, be careful, it's not the same that we did with congruence. You have to show that the sides reduce to the same fraction. So if you can show that 2 pairs of sides reduce down to the same fraction, and the angle in between them, the angles in between them are equal, then you can say that the triangles are similar. Alright, so what we're going to do, I'm going to again do some of the examples out of your packet with you, just so that you can see how to do them and actually get some of your packet done. So the examples that I want to take a look at today for day 2 are the first 2 in your packet, and then we'll go to the ones where you have to figure out what method you can use to prove the triangle is similar. So if we take a look at the first one, it's very simple. The reason it's so simple is that the 2 triangles are sitting in the exact same position. So you have the smaller one on top and the bigger one on the bottom. So what we have here, this side GF corresponds to WV, meaning they're in the same place. And then we have sides FE and VU, again, those are corresponding sides, they're in the same place. So again, we can use that to set up our proportion. I'm going to do, for this problem, I'll do small triangle over big triangle. to set up my proportion. And again, you don't necessarily have to write that down every single time. I usually do just so that I know that I'm consistent. So I'm going to compare the sides that are in the circles. I'm going to put the small triangle on the top, the big triangle on the bottom. So that becomes 48 over x. X is what we're looking for. And then we'll do the same thing with the other pair of sides, the pair of sides that I put in a box. The shorter triangle, or the smaller triangle, is 30, and the bigger triangle is 65, and then it's just a matter of cross multiplying. Now, when we cross multiply, first thing that we want to do is the 48 times 65, and 48 times 65 gives us 3,120, and then we have 30 times x, which is just 30x. So again, we're multiplying across to get those numbers. Now, to get x by itself, we take the 3120, divide by 30, and we end up with 104 for the side that's missing. Now, the second one is not quite as easy, only because the triangles are not sitting in the same place. So if you want to redraw them, you can draw them so that they look a little bit more similar, so that they look like they're sitting the same way. I have this angle up here, and then if you take a look at the two sides, one is kind of longer than the other, and on here one is longer than the other. So the longer side goes in the same spot, and the shorter sides go in the same spot. And again, if you can just see that, you don't necessarily have to redraw it. So now that I have my triangles in the same spot, I want to find corresponding sides. Those sides are in the same place, and those are in the same place, and now I can set up my proportion. Again, I'm going to go small to big, so I end up with 12 over 24 equals 10 over x, and then we cross multiply. On that diagonal we get 12x. On this one we get 240, and then we just take 240 and divide by 12, and we end up with 20. Alright, so hopefully that helps you with the similar triangles. Just draw them so they look alike if you have to, set up a proportion, and cross multiply. Alright, the last thing that I want to do is go to question 17 in your packet for day 2 and take a look at the problems that ask you if the triangles are similar, and if they are, how you know. So really quickly, from the beginning of the video we have 3 ways to prove triangles similar. There's angle, angle, side, 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 and side, angle, side. So what we want to do here is see if we can prove that the triangles are similar or not using the information we're given. Now, one thing I just want to point out on this first one, the photocopier put a line through the entire page, but there are 2 triangles. There's one here, BCJ, and then there's the big one, KJL. Now, what we want to do is figure out if these triangles are similar. Well, the one thing that I want to make sure that you understand first is that these 2 triangles share something. Just like last chapter, we used reflexive an awful lot. We're going to use reflexive an awful lot in this chapter, but we're going to add something that's a little new. This time we can say that they share angles. So the 2 triangles share angle J. So right away we have angle J equal to itself. But then if you take a look at angle L and angle C, one is 94, one is 95. They're close, but they're not equal. Now, if this angle is the same, these are not the same, the other 2 won't be the same. Okay, they all have to add up to 180 in a triangle, and if these 2 are not the same, but angle J is the same, the other 2 are not going to be the same. So for that reason, we can say that these 2 triangles are not similar. It's really close to angle, angle. If this was 94 and this was 94, then we would have enough to say that they're similar using angle, angle, but they're not the same. Okay, next one, number 18. It looks like for this one we are given 2 pairs of sides, and we're given the third thing that we can use here is our pair of vertical angles. So I know for sure that those angles around A are equal because they're vertical. So it looks like I might be using side, angle, side for this one. But what I have to show is that I have 2 sides, 2 pairs of sides that reduce down to the same fraction. So if I look at BA and AF, so BA over AF, well, BA is 18 and AF is 9, and 18 over 9 reduces to 2. Now, if I take a look at CA and AG, CA is 16, AG is 8, they also reduce to 2. So I can use side angle side because I have two sides that reduce down to the same fraction, and I have a pair of angles that are equal. So these triangles are similar, and they're similar using side angle side. Okay, so the rest of them you can try tomorrow in class.